Okay, here we go. Um, these are your notes. We're on page 10 of your notes. Um, Here are our notes from yesterday for rational and irrational numbers, right? Rational numbers, messy, no, rational numbers, rational, so they're nice and clean, nice solid answer. Irrational, messy, with a lot of leftovers in the decimal place. All right, now we're going to do something a little bit different. So, um, one of the things that you want to notice right away is that these have equal signs, all the problems that we're going to work on today. So we're solving equations. And if we look at an example of solving equations, um, so if I had, let's see, uh, x plus 6 equals 10, that's an equation, right? And the whole point of equations is to get the variable by itself. So I would want to get x alone. And to do that, I can think of there's two sides of the equation, right? And the equal sign kind of divides that. If I want to get x by itself, well, then I would have to get rid of this 6, and it's a positive 6. So to get rid of a positive 6, we're going to do the opposite, which is subtract 6. And whatever I do to one side of the equal sign, I have to do to the other side. So I'm going to subtract 6 to the other side. Those two 6's cancel. And then I have x equals 10 minus 6 is 4. So we've got x by itself, and we've found what it actually equals. So that's going to be our goal in these radical equations, is to get x by itself. One thing to point out is x is by itself. It also has an exponent of 1. So that's going to be our goal as well. We want an exponent of 1 by the x, or the variable that we're using. Okay, I'm going to erase that and get to it. So on these, we have our radical, and the first thing that we're going to do, so we'll put some notes here on the side, so steps, is we are going to change the radical to a fraction exponent. So a fraction exponent. Okay. So we'll put some notes here, and then you can kind of move it around and shrink it. So change the radical to a fraction exponent. And you could pause this for a second and write that down. And then that's the first thing we're going to do. So we're going to come over. We've got the square root of x. We know there's a little 2 out there. And this exponent has an exponent of 1. We're going to move that 1 on top of the 2. And so we have x 1 over 2 equals 5. So we've converted it. If it's in radical form, we're going to convert it to a fraction exponent. Now the next thing we want to do is we want x to be by itself, but it's got this fraction exponent. And the way to undo fractions is with what is called a reciprocal. So that is the fraction flipped. So number 2 is going to be flip the fraction on both sides of the equal sign, because whatever we do to one side, we have to do to the other. So flip the fraction on both sides of the equal sign. Okay, so you can pause that and write it down. So flip the fraction on both sides of the equal sign. And then I'm going to show you how to do that. All right, so we have 1/2. I'm going to make a little more space here. I'm going to move that 5 over just a little bit. And so I'm going to multiply by the reciprocal, or the fraction flipped. So I'm going to come over here, and it was 1/2, and I'm going to make it 2 over 1. And whatever I do to one side of the equal sign, I have to do to the other, so that 5 now has an exponent of 2 over 1. On the left side with the x value, we did that so that these will cancel out. Those two 2's will cancel out, and ultimately what we have is x with an exponent of 1, which is what we want. Now 5 has an exponent of 2 over 1. Anything over 1 is itself, so 2 over 1 is just 2. So we really have 5 with the exponent of 2. So our last step then, if we can, is just simply simplify. In this case, 5 to the second power is really 5 times 5, and 5 times 5 is 25. And so that's our answer. And if you think about it, we started out with the square root of x equals 5. Well, x is 25, so the square root of 25 is 5. It's a perfect square. Okay, but our final answer truly is x equals 25. This is more our check step at the bottom here, if we plug 25 back in for x. All right, so change the radical to a fraction exponent. Flip the fraction on both sides of the equal sign, and then simplify if we can. So those are the steps that we're going to practice doing in our notes now. If you needed to, you could always copy and move those steps along with you as you go and solve the next couple with me. So our first step is change the radical to a fraction exponent. So under the radical, I have x to the first, and I'm going to move that above the 3. So I have 1 over 3. And so now I have x to the 1/3 equals 4. I'm going to leave a little space in between here so I can do the next step. So number 2 says flip the fraction on both sides of the equal sign. So flip that so that it cancels out. So I've got 1 over 3, so I'm going to multiply that by 3 over 1. Whenever I do to one side of the equal sign, I have to do the other. And we just talked about that if it's over 1, it just means the same as the number on top. So 3 over 1 is just 3. These cross cancel, so my x has an exponent of 1. And then I have 4 to the 3rd. And so then what I want to do is I can still simplify 4 to the 3rd. So, you know, you can put that into your calculator, or it's 4 times 4 times 4, and that equals 64. So our x value, now that we solved, is 64. Not too bad, but of course they're going to get a little more complicated. So I am going to just copy these steps and take them with me as I move across here. So I'll tap and put them back on my screen so I can see them. All right, change the radical to a fractional exponent. All right, there's nothing out front, so that's really a 2. I'm going to move that 3 on top. So 3 over 2. So I really have x, 3 over 2, and then bring down my equals 8. Again, leaving a little space in between here because I know I need to work there. All right, number 1 says change the radical to a fraction exponent. Oh, did that. Flip the fraction on both sides. All right, so flip the fraction. I'm going to change colors. So 2 over 3. 2 over 3. All right, these cross cancel, which is what I want. So they're really going to reduce to a 1. So I have x. And then I have, now it gets a little more complicated. I have 8 and 2 over 3. My third step, so this was 1. This was 2. 3 is simplify But now it's a little more complicated. So in this case, simplifying means changing it to a radical. Change back to a radical and factor tree. Maybe I'll say and do factor tree. All right, so the simplify, if it's an easy one, we just simplify it. Or we're going to change it back to radical and do a factor tree. All right, so here we go. My strategy to remember how to change it to a radical is to do a little radical sign under the fraction so we know it stays out front. And then at a diagonal, we can see the numbers that go underneath. So we're going to have the cube root of 8 to the second. Okay, 8 to the second. Well, 8 to the second means I have 2 8s. So the cube root of 8 times 8. All right, so I need to do a factor tree now. So I have 4 and 2 and 4 and 2. I need 3 to go out on a date. I don't have any groups of 3, so I'm going to keep going. 2 and 2. 2 and 2. Oh, now I have some like 3 of a kinds here. So I'm going to highlight the ends of my branches. 2, 2, 2, 2, 2, 2. Again, I can write that out so I can see it. I basically have 1, 2, 3, 4, 5, 6 2s. So this equals the cube root of 1, 2, 3, 4, 5, 6 2s. 1, 2, 3, 4, 5, 6. So 6 2s. And I need groups of 3. All right, well, here's 3. That 2 comes out. Oh, I have another group of 3. So those can be represented by another 2 coming out. And when anything I bring out, I multiply. So my final answer goes back to x, right? X equals 2 times 2 is 4. So my final answer after all of that is 4. So lots of steps. We're just going to take it a step by step. All right, so you can pause that, kind of look at it, catch up as you need to, and we'll go ahead and try another. Maybe I'll again circle my steps, copy them, and move that down with me so I can see them. Tap and paste, and I can shrink them a little bit. All right. Well, here we go. Change the radical to a fraction. Now there's a 2 on the outside. 5 comes on top. So I have x 5 over 2 equals 16. Flip the fraction on both sides. So step 2, flip the fraction. I had 5 over 2. So that's going to be 2 over 5 on both sides. Ooh, excuse me. These are going to cross cancel. So I have x to the first power, which is what I want. Now, simplify, change back to a radical and do the factor tree. So I'm going to use my little strategy so I can see what's on the outside. And then my 16 and 2 go on the inside. So I'm going to have 5 root 16 to the second. All right. Well, I need 5 of a kind to come out, and all I have is 2 16s. So I'm going to rewrite that. X equals 5 root 16 times 16. And then I'm going to start my factor tree. Leave a little room here. So 4 and 4 Okay, and those 4s can be broken down into 2, 2, 2, a bunch of 2s. Okay, I'm going to have some 2s here. All right, so I'm going to count those. I've got 1, 2, 3, 4, 5. And then I'm going to do my leftovers in a different color. So those are my numbers. So here's my first group of 5. So those are going to come out. So I have x equals 2. I've got the 5th root. And then those in red, highlighted, there's only 3 of those, so they have to come back under the radical sign. So I've got 2 times 2 times 2. I'm going to have to multiply those back together. So I have 2 5th root. 2 times 2 is 4. 4 times another 2 is 8. So 8 underneath. All right. And that is my final answer. Yikes. Lots to do there. So that's my final answer. Okay. Again, take it a step at a time. Don't try to think too far ahead. Really just try to work through the step by step. Okay, let's try the next one. Here we go. Okay, change the radical to a fraction. So I'm going to bring it over. And again, it's not a bad idea to show your little arrows where everything's going. I have x 3 over 5 equals 2. Step 2, flip the fraction on both sides. All right, so times 5 over 3. 5 over 3 on both sides. These cross cancel. Bye-bye. And then, let's see, I have to put it back into a radical, step 3. Simplify or change back to a radical and do a factor tree. So, let's see. It's a cube root, so I'm going to have 3 on the outside, and then 2 to the 5th on the inside. And I can rewrite 2 to the 5th. That means I have 5 of those. So I'm going to put that 3 on the outside because I need 3 of a kind. And I have 5. 1, 2, 3, 4, 5. All right. And 3 of those, 1, 2, 3, can go out on a date. So these 3 go on a date. And then I still have the cube root of 2 times 2. So 2 times 2. That's not enough to come out. They have to stay in the house. So 2 cube root. 2 times 2 is 4. So my final answer is 2 cube root of 4. All right, we're doing it. Over to 12, same process. Why don't you try, why don't you try number 12 on your own? I was trying to get it to, oh, there it is. Paste the steps. So here are your steps again. And why don't you try to do that without my help? So pause it and see how far you can get doing this. And then I'll just do it really quick so you can see the answer, but really do try to work it through just reading the steps. All right, there you go. Okay. Having done that, you pretty much have what you need to do on your assignment on the next part. Number 13, so in our notes, 13 to 20 is very similar, only we don't have to convert them from radicals. They're already in the fraction form. So all we really need to do then is to solve them. So we can just come in, and I just need to multiply by the reciprocal. These cross cancel. I have x 3 to the second. So I don't have to change that to a radical, but 3 to the second really equals 3 times 3. And so 3 times 3 is 9. All right, so you can try a few of those. You still would have to simplify those, some of those using the radical. But again, just take your time and try. All right, go back into your assignment, homework 7. And you're going to start problems 13 to 18. So you really are going to take your time because there's nothing after that. And then if you haven't finished 7 to 12, you can do those as well. And maybe I'll do a little video for the upper part so you can double check a couple of your answers. But definitely go in, try these out, go back in, watch the video again if you need to, and try some more.